Good morning, guys. So we're in Oceans, Atmospheres, and Climates, and we had started chapter 2. So we're at chapter 2.1. 2.2. Right? So let's go over what we're going to be doing today. We're going to be doing the warm-up. We're going to be rereading Oceans and Motions that we looked at last class. We're going to be investigating ocean surface temperatures. Last but not least, there's a little bit of homework that requires a model for you to do. So let's kick off with the beginning and our warm up. So you're going to receive this map here, and as you see, we're looking at two different cities. So we're looking in Cape Town in South Africa and Buenos Aires is in Argentina. So, do you guys think that the ocean surface temperature near Buenos Aires is the same or different from Cape Town? And why? So you're going to choose A or B, A being that it's the same, B being that it's different. You're going to explain your choice and about why you think it's A or B, and then you're going to click hand in. So Ms. Jackson is just going to click any answer just so you can see the hand in button will light up. Whether you click A, whether you click B, remember to explain your choice. So after you complete your warm up, we are going to move on to rereading Oceans in Motion. So here you'll see your same article and your annotations from last class should already be there. Ms. Jackson's using her account instead of a student account today, so there are no annotations because I didn't annotate my own last time, but you guys should see yours. So we're going to reread and just 3 paragraphs this time. So paragraph 4, 5, and 6, and we have to make sure we're looking at the maps that go with these paragraphs. And as we're reading, we're trying to answer the question, other than latitude, what else affects the ocean's surface temperature? Right, so last time we read this, like I said, we're going to do some annotations. I saw a really great annotation by a student in 601 who had asked some questions, and then as they read some more, they added more notes to answer those questions. I thought that was a really great idea, so I just want to bring up that good point. So remember, we're reading to answer, other than latitude, what affects the surface temperature? So let's scroll on down here, and Miss Jackson's going to skip 1, 2, 3. We're going to go straight to 4. So 4 says the current shown on the map moving away from the equator. At the equator, a large amount of energy is transferred from the sun to the ocean surface. As the current moves north, it carries energy with it. If you place your finger on the map anywhere this current moves, the water there would be warmer than you would expect for a location at this latitude because of the current that moves through this area. So if we look at this image here that I was talking about, right, we see Japan, and Japan's going to be warmer because this current is pushing up water from the equator, right? So we see that in our key, it's a warm current, and so it's pushing up water from the equator, so it's going to be warmer than we would expect other places with the same latitude. Gotcha, that makes sense. You notice how, as I read about it, I went back to the image, and that's what's kind of expected for you when you read these next paragraphs. So, Jackson read paragraph 4 for you. You're going to read paragraph 5 and paragraph 6, right? So, I am going to just do a think about there was. Oh, I think I actually covered everything. Notice that my arrow shows me my direction, right? So the arrow is showing me up. It's also showing me down here with the key that it is warm, right? And so the current starts at the equator, and we know that the equator gets more energy than other places of the globe, right? The equator is where we receive the most energy. So Miss Jackson's gonna add her annotation here, as you guys should be adding yours. So add your indication, warm currents, carry energy from equator. All right. So that's something that explains a little to me. What else is affecting the oceans? What's affecting the ocean's surface temperature besides its latitude? So as you read 4 and 5, you're going to add even more annotations, and then you're going to hit this hand in button. And once you hand it in, remember that you can always hit update, and it allows Miss Jackson to see all the wonderful notes that you're putting in your annotation. It also allows me to see if you're not annotating and why you might be confused, right? So if you're not annotating, I don't know how or what you don't understand. But if you are, then I can go, oh, well, here's where one of my scholars are struggling. Let me help them out. So let's move on to the next activity. So we're going to be looking at 2 maps to gather more information about the investigation current. So we have this current near Buenos Aires, right? That's pushing down. And we have this current near Cape Town that's going by Cape Town and it's pushing up. Before we get there though, you have just finished reading our 5 and 6, right? And so Miss Jackson's going to give you a little sneak peek if you didn't. So the key concept that we should have gotten when we read that was when an ocean current comes from the equator, it brings warmer than expected water to the places it passes. And when an ocean current comes from a pole, right? And we know the poles are at the top and the bottom of our globe, right? It's at the top and the bottom of our maps. When an ocean current comes from a pole, it brings colder than expected water to the places that it passes. So we are going to be comparing, right, these maps. So if we look, we have Buenos Aires here and we have Cape Town here. And my map is just a little bit different than yours because it shows temperatures, right? We know it's warmer towards the equator and colder as we go towards the poles. So let's think about what is happening here. We're going to compare the ocean currents in A and B and match the phrase that describes it. So if I look at A, which is Buenos Aires, I'm seeing that the arrow goes down from the equator, right? So that lets me to know that this water that's going by Buenos Aires is getting warmer, right? Since we learned that the ocean's currents can affect surface temperature, right? We're looking at these locations, and I know that if it comes by, it's carrying warmer energy because it's coming down from the equator. So, let's look at which answer best fits there. Carries no energy. No, that's not what we said. Carries more energy. Carries the same energy. Carries less energy. Oh, we said it carries more energy. So I'm going to drag that and put this there. So now let's look at what's happening with Cape Town. So as I'm looking, this current is going down by the poles and it's pushing up and around. So what's going to happen if it's coming from down? What's happening in terms of that energy? That's right, there's less energy, guys. So I'm going to put this water is carrying less energy than we expect, right? I want you to think about what does this map show us? And does this map provide evidence that the currents near Buenos Aires and Cape Town cause the ocean surface to be the same or different? Thinking back to our do now, is it the same or different? Right, we expect them to be different. So let's continue and move along. So we have two more questions, and that is, which claim is better supported? We already said that we expect these to have different temperatures, so let's read them. Claim 1, Buenos Aires and Cape Town had the same ocean surface temperature. Nope. We should all be choosing claim 2, Buenos Aires and Cape Town had different surface temperatures. Right? We expect them to have different surface temperatures. I want you guys to explain using the words equator, energy, and current, right, how the map supports this claim. So Miss Jackson was talking about what happened at the equator and what we see going on with our currents, right? We have two different currents in terms of energy, and I want you to explain it. Remember that your answers need to be complete sentences. It should not start with because is not a complete sentence. And you should also be answer this question with more than one sentence. I can't tell you how many people had to fix their discussion post because they weren't following what we do in school. So remember, complete sentences, and it's not going to be able to be just one. And you have 3 vocabulary words that you have to use: equator, energy, and current. Once you do all of that, hit the handy dandy hand in. So there's only one more thing that I want to cover today, and that is homework. So we're going to use this sorting tool to demonstrate how warm and cold currents affect ocean surface temperature. So if you click on it, it says 2.2 homework. It takes you to, and give Amplify a second, it takes you to this model here. And notice that some of them are already done for you. So if we're looking over this first current, it's done for us. And there's some things that we should know as we're going to do it. And that is, the star shows you where the current starts from. So this current here starts from by the equator, and it pushes up over here by Asia. So we know that this is going to have high energy. How do we know that? Because it's starting at the equator, and we know that the equator gets more energy from the sun than other places on our globe. So high energy. And as we move up here, the temperature, we expect it to be warmer. So notice how I use the hot temperature because we expect it to be hot. This one here is a medium energy. And how are we going to choose medium is a question that I had some kids ask. Well, we would say if something starts between 0 and 30, right? And this is called the Tropic of Cancer. So 0 to 30. We're going to say that this here is going to be high energy. And then from 30 to 60, right? From 30 to 60 degrees north, this is going to be medium energy. And if it's above 60, it's going to be low energy. Exactly. Let's look at it below the equator. Same, from 0 to 30 degrees Celsius, this is going to be high energy. From 30 to 60 degrees Celsius, this is going to be medium energy. And from 60 and higher, it's going to be low energy. So let's do one together before we run out of time. So if I look at this one right here, I see that my energy is starting close to the equator, and this current is going down and around and ending down here. If it's close to the equator, what energy would we have? Exactly, we'd have high energy. And so what temperature should we have? Yep, hot temperature, right? And so that's how you're going to knock out the next 1, 2, 3, 4, 5. Okay, so that's today's lesson. Looking forward to seeing you guys on Wednesday. Love you. Have a good day.